It's time to learn about shell scripts. Writing shell scripts is one of the most powerful tools you will have, since they allow you to combine all the commands you have learned so far. In this video, I will show you how to write your first shell command and how to tell the computer when to execute it. Simply put, a shell script is a file containing a series of commands. The shell, which is the command line interpreter, reads the file and then executes each of the commands one by one as if they had been entered directly to the command line. Let's create a shell script in the terminal. Before starting, we need to find a way to edit text files directly from the terminal. We can do this by using Vim, a text editor in Unix systems. So in my folder I have two scripts, an R script and a Python script, not to be confused with shell scripts. Let's open Python script with Vim, what.py here. So this is a script to calculate the number pi. We can insert text by pressing the I key. We can move and type something. Enter. Remember, I means insert, and here can insert, for example, print this is pi. To save the changes, we need to first escape the insert with the escape key, and then we use 2 points W, and now it's overwritten. Now we can escape and get out of Vim by, again, 2 points and Q. If we made a modification that we didn't want to make, for example here, we can exit directly by first escaping, then 2 points, Q, and the exclamation point, and nothing will be overwritten. I know it seems a little complicated for a simple text editor, but you will see that there are times when Vim will be the only way of editing text. We just modified a Python script. Let's now run it. We can run it directly from the terminal. Given that you have installed Python beforehand, we can run the script by typing Python and the name of the script. This is Py and the Py number. We do the same with the R script. If we want to see it how it looks, it's a different method of calculating pi. You see it here. We can run it with R script. And it calculates. It's not as precise because it's not as good as a method, not because R is not as good as Python. It's just because of the method. Let's now combine these two commands in a bash script. We open Vim and the name of our script. Look that you can open files that did not exist before. So here we'll write my script.sh. It didn't exist before, but we can open it and it's an empty file. We press the key I on the keyboard to insert, and then we're going to start. The first line is the most important one. Bash. Why? It tells the system the name of the interpreter that should be used to execute the script. Now we can write the lines we want it to execute. First we want to echo, which means print, so print on the console. Let's start. Then we want to run the Python script, Python, what is py.py, and then R script, what is py.r, and I was making a small mistake here. It's R, capital R, and then echo, we finished. We escape with the escape key, and then we write, and then we exit. Let's run it. We will run it with bash. Bash myscript.sh. Let's run it. And as you see, all the commands are run. Let's start. This is py, the py with R, with Python, and then with R. And then we finished. This script consisted of just a list of commands. However, scripting has many powerful features similar to any programming language. There are if-else and case constructs, for and while loops, and many other. With time, you will be able to write more complex shell scripts. How can we know if the scripts are running? Well, we can look at the processes running on the computer. Processes are the way operating systems organize the programs that are running and waiting for CPU resources. Each process is assigned to a number called process ID. To see which processes are running at the moment, use htop. It may be that this program is not pre-installed in your system, so you should use either sudo apt get install if you're on Linux, or brew install on Mac OS. These two are package management software and an easy way to install new software directly from the computer. Let's now go to htop. The upper part of the screen shows a summary of the system, which cores are being used, to which capacity, and how much memory is still available. In the second lower half, we see the processes with their corresponding process ID, the name of the user, the processes, and how much CPU memory they're consuming. Now let's escape with F10. Running scripts on your computer is great, but running them automatically is even better. Crontab allows you to schedule jobs at regular intervals. For example, every day at 5 o'clock in the morning, or every hour at half past the hour, or even every minute of every day. Let's go directly to crontab, and we need to specify -e. The first two lines tell the system where your path environment is. Let's insert and write our command. For this, we're going to need 5 asterisks. Each asterisk corresponds to the first one to minutes, the second one to hours, days, month, and day of the week. Then we, instead of bash, we use sh. And here we have to write the directory where our script is contained and the name of the script. So this you have to put the .sh, the correct ones. And each asterisk means every. So here we have every minute of every hour of every day, this will be executed. If we change this first one to 5, it means that every hour on the minute 5, on every day of every month, this will be run. Or if we write another 5, it will mean every day at 5 o'clock in the morning and the minute 5, this will be run. So 1 every day. A little bit confusing, I know. But there are online crontab generators that will help you to write the correct crontab. You have now learned how to communicate directly with a computer and understood what is happening behind the scenes. Take a look at the reference below to learn more about scripting.